So my state was this characterization framework will help assess new adhesion materials. So essentially I hope to put protective particles through this or a similar process, maybe slightly improved or adapted in some areas, especially depending on certain particles, and hopefully this will allow me to take its characteristics.
Thank you. Second presenter, please.
Thank you for listening. To countermeasure wheel flow problem by measuring wheel friction. In the future, I think we can prevent from wear of red flange. So, yeah.
Please.
Okay, in my paper, roughness can be used as a correction factor for the characteristic curve of adhesion coefficient creepage. Thank you.
My paper presented a method in which you can actually look closer at what is going on in the contact that is caused by rusting, and also that we need to look into more into what the conditions of formation are as well as the conditions of running.
Thank you very much. So I think there was some time for discussing each paper after the presentation, but I hope there are further questions still outstanding, please.
I'm the co-author of the second speaker, Matsuda, and thank you very much for your question and comment about the PQ monitoring bagging. So, and your question, PQ monitoring bagging, and in Tokyo Metro, we lubricate wheel and rail by using the track side lubricator. And we are going to lubricate by using PQ monitoring baggie in the near future. Thank you.
Thank you for this clarification. Other questions? Maybe I have a question to the last speaker. Can you say a little bit more about the next testing phases which you envisage as part of your research? So I understand that you're going to move into a larger scale for your testings.
Yeah. Well, one of the limitations that we found, based upon trying to look at the individual oxides, is that what happened is we got a contact where it was ploughing straight through the oxides as opposed to actually getting it entrained within the contact. So how we're going to explore this further later on is by using a larger, we're using the full-scale rig, which was presented the other day, so that we're hopefully going to get more entrainment of the debris in the actual contact itself, and just anything that isn't a pure sliding thing, such as the twin disc. I know it does have the limitations that I've expressed in the presentation. However, we believe it is necessary to have some form of sliding contact to actually get that entrainment and be able to actually study what is going on actually in the contact.
Thank you. Other questions? Please.
Okay, thank you. I'm quite interested in the opinion of the third speaker. You said that the roughness can be used to get rid of that falling slope, I mean the negative damping, right?
Yeah.
For your case, indeed, I noticed that when you measure that up to 5%, there is no such negative slope. Yeah, it indeed happens. But, you know, in a lot of measurements, there are indeed get that kind of negative slope. So, according to your research, in which roughness that kind of negative slope can emerge, and in which roughness there will be no that kind of negative slope.
好，陈老师能帮忙翻译一下吗？太长了。
哦，我来说一下吧，就是我看你的那个测量啊，它已经测到大概有50个不变吧，然后在这种情况下呢，它都是一个向上的这样一个曲线，没有这个负坡度。但是呢，我们知道在很多研究当中啊，它是有这样一个负坡度的。
对，它会下去，对。
所以
那个范围大概在5%之后，而且在这个，sorry。
Can pay an effort to provide an answer in English. We appreciate it.
Okay, sorry. I will speak English. Okay, when the average is out of 5%, that will be go down. The curve will be go down, and in that condition, the roughness and the condition of the surface will be change a lot. So I will keep my test in less change the condition. Thank you.
Please.
I have a question to third speaker.
Okay, thank you.
In your presentation, there is a formula to calculate adhesion coefficient. In this formula, you used a parameter of mu s, and maybe it is the adhesion coefficient at static conditions. What value have you used? Have you?
Okay.
Yes.
In that picture, you can see that it is very obvious to see that the roughness can change the curve to up or down. So and there is another thing that when the creepage increases and the roughness, the influence of roughness will be increased too. So then that will be a function about the creepage. Yeah.
I think that value will decide the maximum value of calculation result of adhesion coefficient. After your presentation, Professor Matsumoto asked your question, why the adhesion coefficient is high? Because you showed us the value is 0.6. So I thought maybe that parameter is a key value to decide
Which the reason?
Your curve.
Yep. My curve. Yep.
The maximum value of your calculation results, I think.
Sorry, I can't understand it. 静态的就是你是说纯滚动是吗？对对。纯滚动它就是0啊，然后我的测量的值是 0.07。
不是那个值，那个就是那个有一个那个最后呀那个计算公式里头最后呀一个谬的那个 s，那个是不是你设的0.6？所以那个要设0.6，你的计算结果最大值肯定是0.6。
Yeah. The right. Left picture is shown by the maximum, the max, roughness. Yep.
Okay. Maybe I have a question to the first speaker. You showed that the results for the 3 sands you considered are not so much different one from the other, and you also commented that all of these sands were compliant to the UK and Germany, let's say generally European standards. So my question is, do you think that other types of sands maybe not complying fully with the standards would have a better behavior? Or in other words, do you think that the standards are in some way limiting the performance that can be obtained with sanding?
Well, currently there's work on a new European standard which hopes to liberalise it a little bit more. But potentially the UK standard and the German standard are both fairly wide-ranging on not so much the type of sands you can have, but maybe the shape, the size, for so much. I know the French standard's very strict on the other hand, which potentially, I don't know, could do with a bit of wiggle room, but I think it's more based on what people have been using for decades rather than what's been scientifically proven a lot of the time.
Okay, thank you very much. Is there any other question for the speakers? In case there is, oh please, the microphone is coming.
Sorry, I just want to follow up on that question on sand. There are other materials that are used in some railways other than sand, and can you comment on how your methodology may apply to them, for example, aluminum oxide and other ceramics?
So, as far as I can tell, the hope is to expand it onto other particles. Alumina is one I've been looking at to go through this. Yeah, hopefully it will be able to go through the same sort of process with these sands, so all the test methods should be as applicable.
And that you mentioned some new work on the standards. Is that going to encompass other materials other than just sand?
I think the newer European standard will, well, it won't specify sand only. I think it will be called adhesion materials from now on. So it'll be a bit more open to whatever suppliers can produce and what they deem as safe.
Okay. Any other question? If not, I think we can thank again all the speakers.